So in this part, we would look into the spatial information data. Now, as we have discussed earlier also, that today's world, it's more of a digital world. It is a simple fact that everything human beings do take place at a certain location on the earth. And all the time, it has a geographic component, although we tend not to think about it much. So in this part, we would be looking into the spatial information representations where these spatial information represents the features of our world. The spatial information deals with issues, questions, problems in the world around us. The spatial information helps us to understand the phenomena better with highlighting the interrelationship. Needless to say that all these interrelationship are linked to specific geographic location. So the spatial information records the characteristics and distribution of various features in the world around us. And these characteristics and distributions of features we draw out to represent it in a map or in digital mode the spatial information in any for any geographic location. The spatial information can be of all any kind of it. There can be many types of data. Variety of information would be available in the spatial information. It may represent the global phenomena, like in modern day we talk a lot about the global climate change. We also think about many issues where we are highlighting the loss of natural resources. Recently, we had a disease and pandemic which affected all of us, but how they moved away from the core, from where it has originated, it has geographic dimension, spatial information was linked with it. Then another can be the food production, the kind of differences in the physical conditions and also the kind of social and economic conditions which produce any system for food production. My point here is that we need to understand that these spatial informations, they come in different types, in different varieties, and they can represent many global phenomena. Not only global phenomena, the spatial information can also be representing the local phenomena. For example, the discussion about the nature conservation, urban renewable, the pollution, water pollution, etc., or land degradation at specific locations, all of them, they might be local issue. So here what is happening when I am saying global issue and local issue, it is the change in the scale, and the change in the scale makes these issues different. Some of them, they have global orientation, and many of them, they have local orientation. Now, as the spatial information can be of different type and variety, the data used are also having different types and varieties. Their users also use them differently and consider them also differently. For example, a map for a general public is maps in digital form in the context of spatial information. But the same spatial information for a planner is a computerized tool for solving spatial problems, where the planner would be drawing inferences for developing any phenomena and then try to address the challenges and the issues which are related with that specific spatial location. And another can be the spatial information means for investigator a tool for revealing what is otherwise invisible in spatial information. As we have discussed earlier also, that in a map there might be many relationship regarding the phenomena which we may relate it with the any ground related with ground realities. So all of them, they are very important and critical in the context of spatial information. As here you can see the spatial data, the ground realities exist, and when we digitally represent them in spatial format, it is shown in different layers. And all these layers have common ground coordinates. The bottom one is the integrated data, and the upper layers are the same integrated data, but we are um plucking out some individual information out of the ground realities, and all of them, they have some kind of spatial relationship also. For example, the street data, the upper layer, which is representing the street, it will move in such a way that it may not dissect the building. है ना? So that way, I would say that each layer has its own significance, but they are stitched to the ground coordinates, which would be representing the ground realities. So spatial information integrate the data stitched together with the locational attributes. So here you see, here we can say that spatial information science can be said as an integrating technology where all kinds of non-spatial information, they are linked to the latitude and longitude, that is the spatial information, and becomes very relevant in the context of understanding the evolvement of any phenomena over the earth's surface at specific location. Now we talk about the data. Generally, data can be considered to be values of variables. The variables represent the phenomena or its attributes, which are measured, and the value can be numerical, for example, population of a city, or categorical, for example, the national highway or state highway. Data can represent all types of attribute information and may consist of, say, numbers. It may also be represented in text. It may represent the images, or and many other formats can also be taken as which may be representing the data. All in all, I would say the data is a body of facts and figures gathered systematically for one or more specific purposes. Data are created and used as means to help understand how natural and social systems relates with each other. It's not practical to measure everything everywhere at all times. So we measure selectively. And that is why when we were representing the ground realities, we were plucking out some phenomena in one layer. And that is why I am saying that we measure these data selectively. Moreover, the accuracy of data reflect the phenomena which they represent, and they depends on how, when, where, and what aspects of the phenomena is being measured. These measurements contain a certain amount of error also, and the type of error, along with the concepts of accuracy and precision, makes the data very important. The categories are data variables, and what we enter are the data values. So, data are created and used as a means to help understand and how natural and social system interact with each other, and any phenomena evolve, which is represented in the form of data. So data, when phenomena are measured, one or more variables are recorded, they consist of data. They consist, as I have said earlier also, it might be in the form of numerical values, names, pictures, etc. The variables can be treated as is or combined and recalculated to form additional representations of the phenomena. The ability to manipulate, combine, and process data is what allows us to turn a collection of measurements into information that can be used to answer specific geographic questions. Now, if we make distinction between data and information, the information is a data which have processed into a form that is meaningful to a recipient and is of perceived value in current or prospective decision making. In modern days, spatial information is special. Reliance on spatial attribute is what separates spatial information from other type of information. The features of spatial informations are, for example, spatial data represents spatial locations and non-spatial attributes measured at certain times. Geographic space is continuous. Geographic space is nearly spherical. Spatial data tend to be spatially dependent. Spatial information is special because it is spatial. Now, you see, we may pronounce special and spatial more or less similar. They sound more or less similar, but they have great significance in spatial information. It is special because spatial information is relevant. Relevant in the context, it the relevant to its intended purposes. It needs to be reliable, accurate, and verifiable by independent means, up to date and timely, depending on the purpose. The spatial information need to be complete in terms of attribute, spatial and temporal coverages. It has to be intelligible, for example, comprehensible by its recipients. In that context, it has to be intelligible. It needs to be consistent with other sources of information also. The spatial information is special also because it has to be convenient, where easy to handle and adequately protected. So, spatial data and spatial information are pertinent to features and resources of the earth. Here, human activities based on or associated with these features and resources. Here, I am bringing in the discussion the man-nature relationship, which is so important for that phenomena to evolve at specific spatial location. The data are collected and used for problem solving and decision making associated with the geographic space, which has the component linked to it, for example, like location or the distribution of the phenomena in a certain manner and the spatial relationship within a particular geographical framework. So spatial data are special because spatial data are different from other type of data. They are spatially referenced, identified and located by coordinates. They are made up of a descriptive element also, which tells us what they are. I mean to say, here the descriptive element is about the features of the phenomena which is being represented through spatial data. And most importantly, it also has a graphical element which tells us what they look like, where they are found, and how they are spatially related to one another. So you see in this image that how the ground realities they are related to each other for a specific geographic location. For example, the parks they are associated with sand and gravel, the geology of that particular area, the water resource existing at that particular area, the water table of that particular area, the land use which is existing in that particular area. All of them, they are different phenomena which are stitched to that geographic location. And that is why we can say that spatial data have far more information than what actually we can look through our naked eyes. But when it is being represented in digital format, we can extract out some interesting insight from the spatial information which might be invisible in other sources of data. Now, the spatial data have three important dimensions. One is the temporal. For example, you take any event which has happened at specific geographic location, it will have the time component stitched to it. For example, on 26 December 2004, we had a tsunami occurred. So the temporal information related with that event of tsunami is that it has happened on 26 December 2004. The thematic attribute for that particular phenomena is that occurrence of tsunami in Indian Ocean. And the third and most important dimension which is represented in spatial information is that of its spatial extent. Now here I mean to say that the affected area included a large part of the earth, but more specifically the southeastern coast of India. If we take India as the unit of our investigation and analysis or examination, I would say only the southeastern coast of India was affected through by that tsunami. Um, the southwest coast was not so much affected. So that is the difference. And that is where I would say spatial information is so important. We exactly know as to the phenomena which is evolving at specific location, where it is location, and why it is locating only on that specific location. In this case, the the shadow area of the core of tsunami was on other side, so that is why the southwest coast of India was not affected much. So the spatial information science emphasizes on the use of spatial dimension, transforming data into information which assist us our understanding of the spatial phenomena. Just to summarize data as a broad concept, I would say the data include features such as pictures, the binary images, statistical figures, for example, census data, images in the form of, say, satellite images, descriptive details, the details of that phenomena which is evolving at any specific location, and then the events and happenings. I mean to say here the temporal or time related changes and transformations which are taking place at that for that particular phenomena. So the spatial data includes location, shape, size, and also orientation. For example, a particular square, its center, the intersection of its diagonals specify its location. Its shape is, as I am saying, the square. So square would be the shape, and the location would be the intersection of the diagonals, would be the center of that particular square. The length of one side specifies its size, and the angles and its diagonals on x and y axis specify its orientation. So this is what the general way of representing any spatial information. But spatial data includes spatial relationship. For example, the arrangement of three stumps in a cricket ground is a spatial data. You cannot put stumps anywhere within the ground. It generally has to be in the middle of the ground. So that way, this spatial relationship is very important in the context of spatial data representing any spatial phenomena. On the contrary, the non-spatial data, which are also called as attribute or characteristic data, the information which is independent of all geometric considerations which we have discussed in spatial data. For example, a person's height, mass, and age, etc. All of them, they are independent of person's location. Now, it is impossible to ignore the distinction between spatial and non-spatial data. Very clearly, the distinction of spatial and non-spatial data is stitched with the location dimension which we add in the spatial information. However, there are fundamental differences between them. Spatial data are generally multi-dimensional and auto-correlated. You change the phenomena, but if is linked to any spatial location, you can draw some kind of relationship between them. But the non-spatial data are generally one-dimensional and they are independent because they are not linked with the spatial information of that particular location. So these distinctions have implications on spatial and non-spatial data processing and also the storage issues. Needless to say that spatial data are voluminous because all the time they are linked with the spatial location. So they are much more voluminous than the non-spatial data.